Let's just talk about cloud credits real quick. So cloud credits are required to perform certain tasks, such as running analyses or storing results. Users are not charged for the storage of data sets that are hosted on BDC. But when you start using data in your analyses, you will then need to cover the costs of computation and storage of your results. And as I mentioned, users who upload or import their own data into BDC will need to cover storage costs for that data. Now, there's many factors involved in estimating the amount of cloud credits you'll need for your analyses. So computation costs might be influenced by the size of your analysis and the length of time it takes to run. Likewise, storage costs are influenced by the file size and length of time that data is stored. So we have had previous community hours sessions where we've talked about deeper dive into cloud credits and the different costs associated with running your analyses. So if you want those materials, we can link you to them, or if you have specific questions, we can answer those in this session as well. And we do have materials on estimating and controlling your costs and how to write BDC into a grant proposal. So if any of that sounds of interest, just mention it in the chat and we can talk about that. Next slide. And thank you for bearing with me. So just real quick, here's the workflow. If you do want to apply for what we call pilot funding, which we'll talk about in just a moment. Basically, you sign up for the community. The link is on this slide and it's on our website, pretty easy to find. You would sign up for the community, and then from there you would sign up for a workspace. There are 2 analysis workspaces that are part of Biodata Catalyst. There's 7Bridges and there's Terra. You could sign up for one, or if you want to try both platforms, you're more than welcome to sign up for both. From there, you would apply for pilot credits, which again, we'll talk about in just a moment. Basically, we will provide you with $500, Biodata Catalyst will provide you in what we call pilot credits, and you can receive $500 in pilot credits just to test out the system and see if it's something you want to use for your research. All you have to do is fill out a cloud credits request form, which we'll look for in a moment. And as I mentioned, there are 2 analysis workspaces. You can use all the credits on a single platform, or if you want to test out both platforms, you could split your money between both. After your pilot credits have been used, you can apply for additional credits, or you can pay yourself. If you are an HLBS, you can apply for additional funding after your pilot funding has been succeeded or has been exceeded. So next page. Or next slide, thank you. Now this is our cloud costs and credits webpage. If you want to just press play on this this short video, we'll just give you an idea of what the form looks like. It's very simple to fill out, quite basic information that we ask you for. Now on the cloud credits page of our website, it does link to helpful articles on estimating and controlling your cloud costs, along with the form to request credits. So remember to complete the form only after you've signed up for a workspace. And as I mentioned, the form asks for pretty basic info, including your PI and collaborator names if available, your role in your organization. And then at the bottom, it says you must request one of the following, and this is where you would choose the $500 in initial pilot cloud credits. There is an option for additional cloud credits. As I mentioned, we focus on heart, lung, blood, and sleep disorders, so researchers in those areas can apply for additional credits for specific projects. We do monitor these requests pretty closely with NHLBI leadership, so it's not really a sustainable way to pay for large projects. That's just something to note. And lastly, you'll choose your preferred workspace, whether you're doing 7Bridges, Terra, or if you want to try both. And it does take a few business days for these requests to be approved and completed. And that is all I have to say about requesting pilot funding. So I know we kind of scrambled through that a little bit. My apologies again, but I will stop if anybody has questions immediately about cloud credits in general or about requesting that initial $500 in pilot funding to get started. Okay, hearing no questions, I think we can move on to Emily.
Awesome. Thanks, Amber. So hello, everyone. If I haven't met you before, my name is Emily Hughes. I am a bioinformatics systems analyst at Harvard Medical School as part of Paul Aviak's lab. And so specifically what I work on is the Biodata Catalyst powered by Picture platform, if you're familiar with that on the ecosystem. And so I'll be reviewing that a little bit later today, but overall, I just want to talk to you about data discovery. So we can start off with what data is available on BDC. So as Amber had mentioned previously, the data sets that are available on Biodata Catalyst, because this is an NHLBI, National Heart, Lung, and Blood Institute funded ecosystem, the main phenotypes of priority are heart, lung, blood, and sleep-related disorders. And so I think this figure may be slightly outdated now. We've been ingesting some new studies, but this gives you kind of an idea of the general phenotypes that we have available. So you can see majority are blood, heart related, cardiovascular related, but we also have some other phenotypes of interest such as COVID-19 and sleep disorders. So just to give you an idea of the magnitude available on Biodata Catalyst, so we have over 3.4 petabytes of data that are available, and that consists of over 280,000 participants, 490,000 data files, and over 150,000 whole genome sequenced. So it's quite a bit of data that we've ingested and made available to you in an easy, searchable format, which is wonderful to help you get started with your research. As you can see on the second half of this slide as well, we also have quite a few studies associated with the TOPMed data. And so if you're not familiar with the TOPMed program, this is the Transomics for Precision Medicine initiative. And so specifically, they were focused on sequencing the genotypes of individuals from several high priority studies. So I've provided a link in the slides here if you're interested in learning more about that initiative. And so, as I mentioned, Biodata Catalyst is always ingesting new data. So even though we have all of this available, we're always looking to make more available to you. And so if you're interested in browsing a full list of studies available on the ecosystem, you can do this on the Biodata Catalyst website. So here you can see that you'll go to the Resources tab, click on Data, and then you're able to click on the Explore Studies button to get a list of the studies that are available. Which it looks like you're able to search here by study name if you have maybe one in particular that you're looking for. And again, the link is here. So if you're curious, you can use the slides to navigate there. All right, any questions on data availability before I hop into Picture Open Access?
I have one question.
Sure.
So are the data available for one to see and analyze, or there is we need to contact somebody to get approval to see, or there is wall in between?
Yeah, that's a great question. So I'll be in this section actually going over a tool that allows you to search and retrieve aggregate counts before you're authorized to access the studies. But and I think this will be reviewed later also, but Biodata Catalyst uses the dbGaP, so the Database of Genotypes and Phenotypes authorization mechanism. Typically, to get access to a study to the participant level data, you'll have to submit a data access request through dbGaP. And I'll talk more about that later. Does that answer your question?
Yeah, thank you.
Great. All right, so moving forward here. So before you get data access, right, how can you discover data or see if there is a data set that's of interest to you? One of these tools available is called Picture Open Access. So to get everybody on the same page, in case you haven't heard of Picture before, Picture really has the mission to empower researchers to access data. And so the tool facilitates approachable research for all skill levels by allowing researchers to search at the variable value and genomic variant level, to apply filters on these variables to create a cohort, and eventually export this information into a data frame that's ready for research. And you can do all of this without opening any of the raw data files or mapping to data dictionary files. So PICTURE stands for Patient Information Commons Standard Unification of Research Elements. And so as I mentioned, it allows for searching and exporting data at the variable and variant level. It integrates both clinical and genomic data sets across BDC. So as I mentioned earlier, there was that TopMed initiative to sequence the genomes of individuals, and this information is aligned to the participants' phenotypic information as well. So you can search and query both at the same time. And there are two main ways to access Picture. You can use a user interface or a UI that allows you to search available data using queries to build cohorts. So this is very much a point and click interface, which I'll demonstrate later. And the API or application programming interface can be used to export the data once you've been authorized to access a data set and have built a cohort. And so again, I've provided the link here at the bottom of the slide if you're interested in going. So to really understand the value proposition of the Picture tool, it's important to understand what the traditional workflow can look like for accessing these data files and getting your hands on the data. And so based on the dbGaP workflow, right, you submit your data access request and you retrieve access to the data. So once you access the files, then you open the files and you use the data dictionary to decode these files. So then you parse the files, tables, and variables of interest. And eventually, once you've got the decoded data or the human readable version of the data, then you can use that to select your variables of interest, apply inclusion and exclusion criteria, and eventually create your data frame to then start on your analysis. And so after speaking with researchers, this can take upwards of weeks to do just to get the data in a usable format to start on your research. So that's a huge time sink and can be very, very time consuming. Whereas Picture, we do all of that hard work for you so you don't have to. So you can see that this workflow is much more streamlined. The user can just log into Picture, and then from there, you search for variables, create your cohort, and export your data frame. And then you're ready to start doing your analysis and applying your workflows. So it's really jump-starting the research process. So there are two sides to Picture. There is Picture Open Access and Picture Authorized Access. And today, because we're focusing on what you can do before you get access to data, I will be focusing on the Picture Open Access here, which you can see is outlined in this red box. And so just for an overview of what this tool allows you to do, it allows any user with an ERA Commons ID to search any clinical variable in Picture. And so this means that there's no dbGaP approval required to access the data. You can just use your ERA Commons ID and you're able to get in there and start searching phenotypes of interest. The data type that's available is destigmatized clinical variables. And so what this means is after working with the NHLBI to make this data open access or available to users before they have access to the data, we identified several categories of stigmatizing variables, which are potentially sensitive information. So this includes illicit drug use history or mental health status or things like that. Additionally, from this, you can get aggregate counts based on your queries. So I'm able to apply filters and get counts of participants that meet my query criteria, which I'll demonstrate later. And really what this tool is used for is to just explore data sets to request access to. So instead of spending all of this time up front writing up a data access request for a study, you're able to check and make sure that that study actually has data that you're looking for and kind of get some aggregate counts to maybe perform some back of napkin power calculations or perform a feasibility study to ensure that that is what you want to request access to. And then when you put the time in for the data access request later, then it's truly worthwhile and you know exactly what sort of data or participants you're getting. So just to give you a brief overview of some of the different parts of Picture, when you log in, you'll see a data access dashboard, which I'll show you in a minute, but this provides a summary of all of the studies available in Picture. So we mentioned earlier that you can use the BDC website to see which studies are available on the ecosystem. Similarly, this provides you a breakdown of all of the studies available in Picture for you to search from. And then we have Picture Open Access, which is the tool I'll be demoing here in just a second. So instead of going through this, I'll go through it in the live demo. Great. So here we can see that I've already, and just to make sure you can see my Picture Data Access dashboard, correct? I think so.
Yep, looks good.
Yes.
Great, thanks. Just making sure I've got my screens all figured out. Great, so you can see here I've logged in with my ERA Commons credentials, and because I do have access to some studies, you can see that it says that I have access to 32 studies. I could use authorized access, but in this case, we're interested in open access, where I can search from over 60 studies and over 290,000 participants. Scrolling down here, we can see the data access table, which breaks down each study based on consent code and gives me an idea of the magnitude and also some more information about the study. So such as the study focus, study design, the number of participants, number of variables, and if there's genomic data, the number of samples sequenced. Now, what's really helpful about this is that we can see in this access column what I do have access to and what I do not have access to. So you can see I've been granted access to the Amish and ERIC studies, but I do not have access to the COVID-19 Active4A and Active4B studies. Now, if I would like to request access to this, I can click on Request, and this will take me to the dbGaP study page. So I leave a picture, or maybe it will. Sorry about that. All right, well, it would take you to the dbGaP study page where you can click a button to start an official dbGaP data access request. So going back to the previous question, that's the next step you would take to start requesting access to the data. Now let's flip on over to open access here. So I've clicked on the open access tab and you can see that a search bar is displayed. Now, before I search anything, I do want to walk through this results panel over here. So here you can see that this data summary box displays the total number of participants that I can query from. So we can see that to protect the participant level information, this number is obfuscated, but I can get an idea of how many participants are available. So over 290,000. There are no variable filters yet because I haven't searched anything. I haven't filtered on anything quite yet. And what's super helpful is this next box, the filtered results by study. And so here we can see that there are the different study names or study acronyms. So Framingham Heart Study, the SHARP study, COPD gene, as well as their associated dbGaP study accession number or PHS number. So that information is useful when submitting a data access request. We can see the count breakdown based on each of these studies. So in the Framingham Heart Study, there are 15,149 participants. And this is even broken down based on consent group. So if I'm requesting access for a specific consent group or for a specific research purpose, this information is also helpful. And again, we can see that I can tell which ones I've been granted access to and which ones I do not have access to. So that is kind of orienting you onto the open access page. And so here, let's say I'm a researcher interested in smoking status of males. So maybe I will first search sex. And so I've typed in my search term sex and hit enter. And so now you can see that all of the variables that are related to my term of interest are returned. So this could be that sex is matching some of the variable values or the variable name or the variable description. And so we can see that 327 variables may be quite a bit to go through. So over here, I have the option to filter or narrow down my search results. And so this is based on the study. So if I'm interested in a specific study, I can add or exclude that study. And additionally, there are also variable tags. So if I'm interested in only categorical variables, I could add that tag, for example, and filter down my search results. Now, A powerful search tool on here is the DCC Harmonized dataset. And so if you remember me talking about the TopMed initiative, part of the TopMed consortium, they had a data coordinating center, or DCC, that essentially took several of the top priority studies and phenotypes and created a harmonized data set from those studies. And so we have ingested this information as the DCC harmonized data set, and it allows you to query multiple studies at once that are involved in the DCC harmonized data set. So let me add a filter and hopefully it'll become clear what I mean here. So I can see from the DCC harmonized data set, I've narrowed down my search results to contain only that study. And I see, okay, annotated sex 1, subject sex, that seems like a good variable for me to filter on. So I can click the filter action. And here we see the available values to filter on. And as I mentioned, I'm a researcher that's interested in males. So I can select the male value and click add filter to query. And so now you can see a few things have changed. The total number of participants has been updated to reflect my query criteria. So this means that there are about 32,277 males that participated in the DCC harmonized dataset. I can get a summary of the variables and filters that I've added. So you can see that on annotated sex 1, I've included males. And then you can see that the values for each of the studies and consent groups have also updated. So we can see how that in FHS, the Framingham Heart Study, there are about 7,000 males that participated in that study that were part of the DCC harmonized dataset. So let's take this a bit further. Let's add a BMI variable, for example. So I can search BMI. Again, I can see the variables as part of the DCC harmonized data set. And I see this body mass index calculated at baseline. So I want to filter on that. If I click the filter value, I can see that this looks a little bit different. Now this is a continuous or numeric value or variable, excuse me. And so we can see here that I can enter a minimum and a maximum value. And to help you out, we display the minimum and maximum value that exists in the data to help you to create a more meaningful query. And so here I can add, let's say, minimum of 20, maximum of 50, for example. And I can click add filter to query. And so again, I'm narrowing down the cohort, right? I'm adding males that have a BMI between 20 and 30 in the DCC harmonized data set, and there are about 30,630. And again, the values down here are updated. So I'm going to change for the scope of my research. I know I said smoking originally, but let's say I'm interested in asthma, right? So let me search for asthma. So I can see that there are no results for the DCC harmonized data set that relate to my search term asthma, but that's okay. So let's remove this tag. And now I'm able to see all of the asthma variables that are available across all studies. And so let's say I'm interested in the MESA study, which I think is the multi-ethnic study of atherosclerosis. So here is asthma. That seems like a promising variable to filter on. So I can click filter. I see the values that I can filter on. So I'll say I'm only interested with either yes or no. I'm not interested in participants that don't know their asthma status. I can click add filter to query. And now I have a much more narrow cohort because I've added a filter specific to a study that was part of the DCC harmonized data set. So you can see now for the other studies, there are 0 participants, but in the MESA study, because we are filtering on a MESA study specifically, there is a count associated with those. And so you can tweak your filters, you can add different filters, you can explore different variables across different studies to get these counts and understand what sort of data exists and how many participants have the data you're looking for prior to requesting access for your study. Any questions on Open Picture before I wrap up with submitting a data access request? Again, all you need is an ERA Commons to log into this and get in there and exploring the data yourself. You don't need to have access to anything. Great. All right, so flipping back over to the slides here. Oh, not share. Slideshow. So the next step after discovering your data on potentially BDC open picture is to request access to it. So to submit a data access request, as I mentioned, we use the dbGaP infrastructure for managing access to controlled access data. And so the requirements for this are an ERA Commons account. So as I mentioned, that's what you need to get onto Picture. You will also need one to submit a DAR. And you also must have a principal investigator status. And so those who are not PIs can ask their PI to add them as a data downloader. And so there are several components of a data access request. There is a research use statement, a non-technical summary, and a Biodata Catalyst specific cloud use statement for which we have template language available for you to use. And so we have put together some documentation. So you can see the submitting a dbGaP data access request page of the BDC Git book, which I've linked on this slide here for more information. All right, so I'll pause there to see if folks have any questions. And it looks like I'm joined by Jessica, my coworker. So Jessica, if I've missed anything, feel free to chime in.
We did launch a poll as well, just curious about if people would like additional help getting started on BDC is one thing we've noticed. Maybe finding data of interest. Maybe you're just not sure where to start, or maybe you have found your data of interest and you're not sure how to submit that data access request. Emily mentioned we do have documentation with step-by-step how to do that. Actually, Jessica put that together. Thank you so much, Jessica. That's been a really helpful resource for people. That's a good place to start, but if you're really lost, feel free to let us know, and we are more than happy to help you. And we can answer questions. Even if you don't have your ERA Commons, we can, or sorry, with open access, you can still explore if you don't have that data access. So as long as you can get into Picture Open Access, we can help you look for those data sets of interest, and we can help you with submitting that request just to get you up and going. So please don't be shy about contacting us or letting us know to contact you, and we will work with you to get up and running.
And I just want to also put a little plug in. I didn't run this by Amber in advance, but I just realized that there's an initiative that's not funded by NHLBI, by the NIH, called Aim Ahead. And it's about artificial intelligence and machine learning for underrepresented populations. And all of their programs, they're called for proposals for various consortium development projects, research fellowships, leadership fellowships. They all just went live. And one of the data sources is Biodata Catalyst. So it's a really great opportunity. The fellowships are early career, which I think is defined as 10 years, right? Like early is a vague concept, but the fellowship programs are open to those early career investigators. And then the other ones are for more established researchers who have a bigger projects that they want to pursue. But Biodata Catalyst is a source for all of those programs. And I'm going to throw the link in there so you guys can see. Let's see. And I didn't run that by because they literally just went live. But it's not affiliated officially with NHLBI Biodata Catalyst, but because they are using that source of for data, it is bringing you guys to Biodata Catalyst and providing funding and cloud credits for that work.
Yeah, that's a really good point, Jessica. Thank you for bringing that up.
Yeah, and if there are data access questions related to that, we're happy to help as well.
Okay, so getting back into the presentation, I think if there are questions, of course, feel free to raise your hands. You can unmute, use the chat. We are monitoring all of those things. I will give a couple seconds now to make sure there's no follow-up.
I know there was a question that someone had submitted earlier, Amber. Would it be okay to cover that quickly?
Yeah, for sure.
So I believe the question was, can we add to a new relevant dataset request by building upon our already approved dataset? It really saves time for paperwork. And Jessica, I wasn't sure if you had insight into that.
I do actually. So yes, you can. So I have added data sets to an existing request before, especially when it added, it was similar enough to the project. If it's a completely different project, then no. But if it's related, similar, and you can make that justification, absolutely. You can also, they have a new feature they rolled out a couple years ago where you can remove data sets you're no longer using, which is really handy because some of them require special approvals or that might take a little longer. So if you're no longer needing access to data sets, you can also easily remove them and retain other parts of your data access request.
Awesome, thanks for that.
Great. Okay, if there are no other questions, then I think we can jump into this last section, and there will be time for more discussion and more questions at the end. Kat from Terra had a conflict today, so I will be taking over her section. I'll try my best to get through the slides that she provided. Hopefully I don't butcher it in the way I did the first session, but if we want to jump right in here. Next slide. Okay, so while you are waiting for your pilot funding, there are some things you can do on Biodata Catalyst powered by Terra, which, as mentioned, is one of the analysis workspaces on Biodata Catalyst. You would start by going, so say you're brand new and you want to launch this, you want to launch BDC powered by Terra, you would go to Biodata Catalyst website, and under the services area, there is, as you can see in the screenshot, thank you for annotating, Dave, there is a launch link, and you would click that. Otherwise, if you've downloaded today's slides, the link is already here. But this is where you would launch actually any part of any of the services that are associated with BDC. So Dave will talk about 7Bridges in a moment, but this is where you would launch. There's also documentation available for each of the platforms. This is separate from the BDC explicit documentation. So if you're new to these workspaces, you could launch the documentation to learn about them. You sign in with your Google account. And note that you are not initially linked with any of the frameworks. So your Terra profile is not linked to any frameworks at this point. Next slide. And if you are really eager to get started with creating workspaces, you can actually request $300 from Google in free credits to explore Terra. Now note, this is different than the $500 in pilot funds that we talked about at the beginning of the presentation. So this could get you started working on Terra, and it's a pretty quick process to go through, and there's documentation available for that. Next slide. And finally, we do recommend checking out the showcase section, featured workspaces it's called, and you can see the different workflows, which are WDL based for Terra, and the different notebooks that have different groups that different groups have created to showcase different types of analyses that can be done. And that is just a quick little overview of how you can get started on Terra. Are there any questions? I'm not sure. Oh, we have one more slide. Apologies. So if you want to set up additional funding, there is documentation. Looks like we have a nice flow chart here on depending on the funding type, if you're using a credit card or if you have a grant or award, depending on how you pay for your cloud costs. We have a nice diagram here to set up additional funding. Can't promise I can answer anything, but does anybody have questions immediately about BDC powered by Terra or getting started? Okay, Dave, I think you can take it away.
Thanks, Amber. Let me know if my mic is too low or too high because I have a new microphone. So my name is Dave Robertson. I am the Community Engagement Manager for Biodata Catalyst powered by 7Bridges. Great to be here. I'm going to talk about 7Bridges on a budget. So to say, this is before you're getting your pilot funds from NHLBI, either the 500 or the 250 we talked about, or before you've identified some other funding source to hook up. So you can do lots of things. You can obviously create an account, browse public projects, public apps. I made a little bit.ly link for you because, and I'll put it in the chat. Let me see if I can multitask here. bit.ly/BDC-apps. So the great thing about the public apps gallery on Biodata Catalyst, it's you don't even need an account, so you can see the 824 apps and if they pertain to your research. So you can do that. You can query genotypes. So phenotypes are covered by Emily, and you can query genotype data, including NGS, VCFs, and CRAM files from the sequencing machines in the data browser. Now, there's another feature called the Study Variable Explorer you can use. There is some overlap with Picture, and I'll talk about it briefly, but that's another way to look at sort of aggregate counts of outcome or covariate variables. And finally, you can get your projects ready. So you can make as many projects as you want. You just can't run the compute. Okay, and then there's some longer links here about funding, how to write your BDC into a grant, how to do guide to what's called building groups on Biodata Catalyst. Okay, so obviously create an account. The link's down at the bottom. You can log on with your ERA Commons and then log in with the ERA Commons. You can also first create an account with ERA Commons. That's the preferred method. That'll automatically forward your dbGaP authorizations if you authenticate with ERA Commons. There's also another way. If ERA Commons is a problem, we want to know, there's alternative instructions I can ask, but hint, it's just pretty much click this button. But please let us know if ERA Commons is a problem. We want to know. Okay, so first thing, explore the public apps. So these are analogous to the public workspaces on Terra. Everything else you have to log on to see, not open to the to just the general public. You have to actually log on. But these are great because they're it's an entire project that you can copy or read about. So there's a great one for if you want to learn about SAS Studio, which you can run on the platform. There's these are just the highlighted ones. There's another one about machine learning and COPD. There's one that walks you through how the top mid variant calling pipeline works, especially for Freeze-8. So you can actually copy these projects, clone them, and look around. You just can't upload new data or what's it called? Run compute. So you can browse public projects. You can browse public apps. So here's that link again. There's 824 common workflow language workflows that help you enable your research. And I just highlighted a couple different things. A new one, which we're actually going to talk about next month in detail, is the STAR pipeline. So this is a highly requested pipeline for doing genotype phenotype associations. And it's this allows you to run the Bioconductor STAR R package using the GUI and also scaling it in the cloud sort of effortlessly. Of course, the most popular app we have is the Genesis apps. So we have single variant, aggregate variant, sliding window variant. So these are also genotype phenotype studies. And there's a public project that walks you through how to do that. And I just want to throw in something different. If you're into RNA-seq or have a lot of transcriptome or other types of RNA work, we have all those apps as well. So I had to give a shout out to DESeq too, of course. So that allows you to do differential expression. said a lot. Any questions? I have a few more slides, but any questions so far about the apps or the public projects? Okay, so you can interactively explore the NGS data with Data Browser. So remember, pictures for the phenotypes. Data Browser on BDC powered by 7Bridges is for the genotypes. So, and the main screen looks like this. So you have everything's broken down by heart, lung, blood, and sleep for the most part. So you have all the heart diseases. Now these are top med studies. So heart, lung, blood, sleep. You can query them. You can see what files are available. You just can't link the files to your project. There's also COVID-19, which is also controlled. So you'll need dbGaP authorization. Then there's a category called Other, which includes, first of all, the TopMed combined exchange area files. We get a lot of questions about this. That's also controlled. You need certain permissions to get there. But that does include anything that the TopMed DCC decided to share. The popular thing there is the GDS files that are combined across multiple studies, as well as principal component analysis files and other things. Okay, now the bottom four here are completely open. So let's say you don't have any funds, you don't have any controlled access, you can still log on and be able to sort of add these files to your project. So we have the 1,000 genomes projects, including BAM files, CRAN files, and variants, and then all this BioLink training data. And this is what, it's a graphical interface. So you have entities that you can assign properties. So in this case, I just picked the file entity for MESA, which is one of the TopMed studies, and I wanted to find all the Freeze-8 files. So this actually gives me only 46 files because in Freeze-8, the hosted data on Gen 3 is the aggregate BCF files by so 23 for consent group 1, 23 for consent group 2 for MESA. So if you had both access to both consent groups, a lot of times the first step is to combine those. Okay, so there's something else called Study Variable Explorer, which is open as long as you log on to the platform. And these slides were created by my colleague, Arti Krishnan, so she's on the call. She can give you a demo of this. There is some overlap with Picture, but definitely default to Picture and Emily's expertise about phenotypes here. But this is one interesting thing about the Study Variable Explorer is if you happen to be on 7Bridges, you could query sort of similar sort of aggregated information. So in this case, we're going to walk through ERIC. So you type in ERIC, you pick that. And then let's say you wanted to type in height, it would give you all the accession numbers for height, or where height appears in the description. And then you could take notes or tag them. So here's an example of tagging height and weight across a couple of consent groups, or I think, and then you can of course write some notes and stuff like that. So it will give you some charts, some plots about the distribution as well. So the most important thing I want to leave you with is to prep your projects. This is the last slide. So the most important thing I think is to create projects. They're free to create. And even if your pilot funds has 0 cloud credits in it, you can still make them. So I did an example here of the MESA GWAS study. And I just put a note in, in theory, I'm not funded for this yet, but I can still add the hosted NHLBI files because those will always be hosted by NHLBI. So you're not copying the data. You're just adding a link to those data so you can sort of stage them there. You can stage your GWAS app, so you can decide, do I want to use Star, do I want to use Genesis, EPACS, Plink, or all of the above. So you can add those to your apps tab. And most importantly, you can add collaborators. So I've had RT here and Tony Patalunas. So all of this you can do without funding and sort of, and I see Ajit has a question. So I'm just about done here. Yeah, so that's it. So let's have discussion and questions. Ajit, if you want, could you ask your question to the group if you have your microphone?
Yeah, I can ask that. So I tried exploring this platform like some time back, and there are like multiple places like I will like click this link, go here, submit this request. So ultimately that discouraged me, and like I stopped working on this. So can we have like one request for like okay, we have been granted for like this kind of thing, so you can perform this kind of analysis, and like I'm saying like that discourages people. So like say in Pixie, or like as I asked in the chat, you get to know that like okay, this kind of like after applying say 2 or 3 filter, you know, like 30 or 40 or like say 1,000 patients are there. Can we get to know that like whether genotype data is available for them or not? Yes or no in that set only. Rather than like again going to some different platform and trying to link them together. So yeah, that's my question. So you got the sense that like I think that this could have been made like little bit more simpler. If that's possible, then that will encourage people working on it.
So you're asking, that's great feedback, by the way.
Yeah.
So you're asking about the genotypes in particular. So you theoretically use picture to identify a number of participants. You made your cohort. Now you want to identify the genotype availability. Let me sort of see how we can. I'm going to actually log onto the platform. I could have missed a couple features actually, but this is a great feedback. Any other questions from the group that we can help with while I'm looking something up?
So Picture does also have genotypic data. It's just not in currently not available in the open access portion. But it does have the ability to combine phenotypic data with genomic data once you have authorized access.
I forgot an
Okay.
entire feature, guys. So in the last 3 minutes, I want to talk about this. So I've logged onto the platform. So I think this may be sort of what you're talking about. So this is all about looking at genotypes in an aggregate form. And you just have to say that you accept the terms of use here. So it does at a sort of a high level, like you can look at a specific variant, and it would give you the percentage of the samples in that study that have that variant. Now, I'm not sure you could cross, I don't think you could do a union with the picture cohort yet, but this will get you closer, I think.
So like to like say it clearly, like I wanted to look that if particular microbe linked to SNP, and they are also linked to some metabolite. And I tried doing that like for some time, but I found it like really difficult. And maybe that my background is like not so much in bioinformatics. So that's one barrier I'm facing. So if you can help me, or like maybe I'll have to figure out my ways to learning
No,
more bioinformatics. Yeah.
no. We're all about helping you. So we can figure this out together. There's a couple of things you can reach out to us via email. We'll put our
Yeah,
emails in
I
the
think
chat.
that makes sense.
and we'll figure out a solution. But just to clarify, you have are you looking for top med studies in particular to apply to that have some of these like omics, additional omics features, right?
Yes, so I did some manual studies, like where I looked into like all the published data and tried to put them in Excel and try to connect them using and like identify some SNPs that are like not highly significant, but that they are connected to some other heart failure risk factors. So I did get some success with that, but I know this is not the way to do it. It needs somebody with like more expertise in this. And maybe like I think I already got in the chat box email address of Emily, so I can write to you or like to other people and see like how
Yeah, definitely send Emily, and thank you, Ajit, but this is really interesting. Send us an email. So
Yeah.
we're going to see your options, and we're always trying to, so what is your primary, so the genotypes that you want to focus on, I think we're just about time. Well, why don't we discuss that over email, and I think we can find a solution for you.
Thank you.
Thank you for your question. I'll hand it back to Amber.
Thanks, Dave. We do have 1 minute left. Some of us do have free time after this if people want to stay on and chat if we have questions that go long, but I do encourage you to submit any unanswered questions either to our help desk or to the emails that our representatives have listed. And those of you that answered the poll, there is still time if you have not. If you answered the poll, we will be in contact with you if you wanted us to answer questions that way. But in the meantime, any last minute questions we will take, maybe just one more if you have them. Otherwise, we encourage you to submit questions, contact us, and also sign up for our May community hours, which will be focused on those newly published apps that Dave was talking about earlier. So we will take last minute questions if you have them. Otherwise, we will wrap up and talk to you next time. So any last comments? Okay, well, we appreciate everyone joining today. I think we had some really good discussion, and those of you who are looking to get in contact with us, watch your emails, and of course, watch your emails for the recording and slides from this session so you can refer back to them later. And we thank you again for joining us, and we hope to see you next month. And thank you, Jessica, for joining us as well. Nice to see you again.
Thanks for having me.
Okay.
Thanks, everyone.
Have a good afternoon.